Hey y'all, third time the charm, let's do this. We're doing 5B, which is polynomial graphs. Now, last time we did graphing polynomials, which was talking about going from the equation to the graph. And basically, we're going backwards today. We're talking about polynomial graphs, and then we're talking about the minimum and maximum and stuff like that. It's kind of like vertex from chapter 3, but we're talking about them in terms of polynomials, so they're not quite all called the vertex here. But let's talk about it. All right, so first of all, we have the absolute min and the absolute max. So that's the highest point, and it's the highest point, like it's capitalized. This is Mount Everest of the world, okay? It's the highest point in the entire graph or the lowest point in the entire graph. You'll either have one or the other or neither, but you'll never have both. Now, what about like kind of high points that aren't the highest point? Those are local. So a local max could be like Little Mountain. Like it's a high point around here, but it is not the highest point. You know what I'm saying? Same thing with local minimum. It's a low point. So it's like a little valley, but it's not the bottom of the ocean. Let's do an example on a graph. I did one just now, but I didn't like it, so I erased it. I didn't erase it. I used my whiteout. I need Frixon pens. Gosh darn it. Okay, so this one right here, this is the absolute minimum. It is the lowest point in the entire graph. This one is a little hill. It's a little bump. It is a local maximum, but it's not the highest point. And then this one is a low point, but it's not the lowest point. So that's a local or absolute minimum, a local maximum, and a local minimum. That doesn't have an absolute max. I think I just said that on accident, but I'm also really tired and need to go take a nap again. So there is no absolute maximum because this one and this one go up to infinity, which is kind of what we talked about last time. This would be like as x approaches negative infinity, as x approaches infinity. That's this stuff. So these go on forever. So there's no absolute maximum. Technically, absolute maximum would be like infinity, but the real trick here is deciding whether something's an absolute minimum or a local minimum. So you kind of have to be careful on those two. Okay, let's also talk about how to find the roots in a graph. All right, so roots are the solutions when the function equals 0. If it's a real root, it's an x-intercept. If it's a complex root, it kind of goes like whoop. I'm going to show you in the graph because I don't really know what to call it. I used to call it a turn, but like everything's a turn, and I didn't want to confuse you with extra language. So let's just look at an example, shall we? All right. So we should know from last time that this has five roots because it has 1, 2, 3, 4 turns in it, plus 1 is 5. So it should have 5 total roots. But it only has 3 x-intercepts. 1, 2, 3. If this was numbered, it'd be like maybe 1 and 4 and maybe -5 or -4. But those are the real roots. And then it has this little whoop up here. There's a complex root chilling in there. That's a complex solution. It'll have an I in it. And then remember that every I has a negative I. They're always plus and minus. And so this will have a plus and a minus I. You know. So that's 5. So 1, 2, 3, 4, 5. Beautiful. Let's talk about factored form now. So factored form is an equation for the graph that's factored completely. Now, this sounds kind of weird, so it sounds like we actually have to factor it, but no, it'll just look like that. It'll have parentheses, 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 parentheses. Let me show you an example. So here's my example. Notice that I should have 3 roots. 1, 2, add 1 is 3, but I only have 2 showing on the graph. I have -2 and +1. There's no like whoop, whoop somewhere else. So it's just these 2. So this one, see how I went? What really happened was it went through the graph and then it went through the graph again, but we can't like zoom in enough to see that. And so this one's actually, it's like twice. So then what we do for the factored form is that we go f of x equals x plus 2 opposites, and then x minus 1 twice, which means squared. So notice that this said -2 and the other one is a +2. And then this was +1 and it turned into a -1. So this is opposites. Okay, keep that in mind. All right, now let's use the graph and knowing factored form to find a factor. And then I'll show you. Let's just do this together. So I did some lines because we're mixing together chapter 5 stuff and unit 4 stuff, but you can use a graph to find a root for synthetic division and you can factor and solve from there. Let me show you what I mean. Okay, so I have this here. I have x cubed minus x squared plus 2. It's only 3 things, so it's probably an X puzzle, but this is not double the power of this one. It's gonna have to be a 4 for an X puzzle to work. Plus, I don't even know if you can factor 2 and -1. You totally could. No, you can't. It has to be -2. So this won't even work for that either. So what we're gonna do instead is we're gonna look at the graph using Desmos, like this. This is not the graph. I'm gonna show you the actual graph. So over here in Desmos on the side, which you can't quite see, hold on. Oh, I was doing it on Desmos instead of over here. Okay, so on the side here, you can type in, oh, let me show you where I came from. Sorry. Here, desmos.com, click on graphing calculator. It'll take you to that site. Okay, so we're going to type this in, x cubed. For x cubed, you're going to do x, and then shift 6 for the up arrow, and then 3. And then minus x up arrow, 2, and then plus 2. So there's my beautiful graph, and this actually confirms my suspicions. There is definitely one root down here, but then it goes a little whoop, so there's another one that's kind of chilling above the axis, so we got to find it. So I'm going to assume that I'm going to have one real root and then 2 complex ones with a plus and a minus I. Okay, so let's do it. So I know that on here, let's actually see. Can you tell what this looks like from your screen? Closer. Okay, so so that's at -1. Do you see it? Also, you can highlight over it and it'll show you, but that's at -1. So I'm going to use the -1 in my x in my synthetic division. I'm not going to change it to a positive because -1 is the root. X plus 1 is the factor. X plus 1 is the factor. X minus 1 is the root. This is where so many people get points missed because they mix the things up. Okay, so then I use my synthetic division. 1, -1, missing x, that's 0, and then 2. And I go whoop. Okay, so I drop down the 1, multiply and add, multiply and add, multiply and add. Multiply, that's -1, add, that's -2. Multiply, that's 2, add, that's 2. Multiply, that's -2, add, that's 0. Beautiful. Mwah. Okay, so then I get, this is basically an x plus 1 and then an x squared minus 2x plus 2. Can I factor this anymore? Can this frickin' be in focus? Okay, I can't factor this anymore with an X puzzle, but I do need to find all roots. That's what it said. And I know I can't factor with an X puzzle because it's above the axis up here. It's hovering above. So I need to do something else. Now, your options are to do the quadratic formula or do the quadratic formula. So which do you pick? Yeah, I picked the quadratic formula. So this one will just tell me it's x equals -1, I'm done. But this one I need to use the quadratic formula. So remember that it's ABC. I don't really want, okay, it's fine. A equals 1, B equals -2, C equals 2. Now, I don't want to say, I want to save the space so I can draw the graph over here. Let me see if I can just do that. So it went through at -1. And I went, whoop, something like that, right? Yeah. So that's the -1 that I got for my synthetic division, and then the rest are up here. Okay, so I don't really have enough space to do the quadratic formula, but I'm going to set it up for you, and then I'll tell you what the answer is at the end. So remember the quadratic formula is x equals -b. Oops, I should actually do the numbers. -2 plus and minus the square root of -2 squared minus 4 times 1 times 2 all over 2 times 1. Which I'm going to clean this up pretty quickly. So I get 2 plus and minus, that would be 4 minus 8, so the square root of -4 all over 2. And then we know this is 2i, right? So it'll be 1 plus and minus 2i. Nope, 1 plus and minus I. If I divide everything by 2 after I take out the 2i. Okay, so there's my first one, and there's my second and third. So there's all 3 roots. We did it. Boom. On a test. This is going to be multiple choice, not multiple choice. Check all that apply. So you'd have to check this one and check both of these, 1 plus I and 1 minus I. Okay. It could be something that's not quadratic formula. So sorry. It could be a X puzzle. No, it could be a complete bleh. Were you equal it to 0 and then you solve it with your art heart? What's that called? Square root method. There we go. It could be square root method or complete the square. No, or quadratic formula. I'm done now. But either way, you'll get all 3 answers because it's 1, 2, 3. Okay. By golly, I hope that helped and was worth it. And I hope you have a beautiful weekend or week or day or whatever today is. I hope that it's beautiful for you. Okay, bye.